Okay, so another type of situation that you might encounter as you do your problems is you might need to find the distance between two complex numbers. Okay, so what does that mean? What is a distance between two complex numbers? Well, if I have two complex numbers and let's say they're on the argand plane, remember we're talking about the complex plane here, which is the same as the argand plane. If I have two vectors like this, and I need to find this distance, well, if I can create a vector between these two points, then I can find the magnitude of that vector, and that vector, that value, the magnitude, would be the distance between those 2 points, right? Between those two vectors, vectors or complex numbers. So we do it just the same way, in exactly the same way that we find the distance between two vectors. Okay, so if I have this vector A and vector B and they both emanate from the same point, and I want to find this vector between them where I'm starting from B and going to A, okay, what I can do is I can flip B, so it becomes minus B, and then I geometrically add those. So I have minus B plus A, which is the same as A minus B. Okay, so that's how I would find the vector between 2 points. Okay. Let's go back to our complex numbers example. If this was z1 and z2 and those were represented as vectors, what I could do is I could take one, depending on which one I want to start with, right? Which point I want to start with. If I want to start from point 2 and go to point 1, then I'm going to flip z2 around and make sure that they're pointing in the same direction, right? So that they're connected in a train form. So this becomes minus z2 plus z1, and so that resultant is z1 minus z2. Okay. If I wanted to find p1 to p2, could I use that vector to find the distance? Yes, I could. Okay. In that case, then I would just have I would flip this one. So I'd go from here. If I wanted to find this vector, I'd go minus z1 plus z2. So this vector would be the opposite of this, okay, the negative of this vector. All right? So once I find that vector, the distance between those 2 points then is the magnitude of this vector. So vectors are very convenient for finding distances between 2 points here. Okay, so here's kind of the summarized rule. If z1 is equivalent to op1 and z2 is equivalent to op2, where those are both vectors, then the modulus of z1 minus z2 is the distance between, p1 and p2. All right. Now we also can connect complex numbers to coordinate geometry. Okay, and so you might see some questions where they give you a type of geometry problem and involving complex numbers. And so you'd have to use complex numbers to solve that. So you can see that if I have a plane, I could, let's say I had this geometric figure, this parallelogram, formed by these two vectors, z and w. Okay, the vector z is really the same as the I should say the complex number z, because this is assuming the complex plane. The vector oq is z, and op is w. All right. So this vector here is really the same as w, and this vector here is the same as z. Okay, so OR would be this vector right here. Okay, that would be z plus w, right? Because I can shift vectors around. So OR would be z plus w, and OM then would be half of OR, right? That would be half of OR, which would be really half of z plus w. Okay, so this is kind of the trick that you'll probably need for some of the questions in your homework to find the midpoint of the distance between z and w. All right, I can take halfway. I can find OR. Okay, I can add these two, and then divide that by 2, and that would give me the midpoint of these two. Okay. So let's try an example here. The problem says P and Q are 2 points on the Cartesian plane. Use complex numbers to find the distance PQ and the midpoint of PQ. Okay? So if, let's see, we know that P23 and Q61 are 2 points. How do I use complex numbers to find the distance PQ? All right, well, let's write these points as complex numbers. Okay, so really they're vectors starting from the origin. So let's say z1, or just z, is equal to 2 plus 3i. Okay, and let's say w is equal to 6 plus I. So now these are two vectors, or two complex numbers. What I could do is, because the distance between P to Q, and these are two vectors, we said up here that we find the vector between 2 points, or the distance between 2 points, by doing z1 minus z2, right? We take one vector and subtract it from the other. Which one do? We take the starting point and make that the negative number. Okay, the starting point is the negative one. So over here, if I want to actually, since I find the distance, it doesn't really matter which vector I choose. I could do z minus w or w minus z. Let's just, for consistency's sake, just do z minus w. Okay, that would be 2 plus 3i minus 6 plus I. Okay, and that would become then 2 minus 6 would be minus 4, 3 minus 1 would be plus 2i. Okay, so we have minus 4 plus 2i is this vector, or this the vector z minus w. I can find the magnitude of that, okay, and that would give me the distance, right? So I just take the components, square them, okay, and we end up with root 20, okay? So PQ then would be 20, all right, 20 units. Now, for part B, it says the midpoint of PQ. The midpoint of PQ is what? So we have to go back and think, how do I find the midpoint of PQ? Well, that's really just going to be the addition of these two vectors, or two complex numbers, right? And then divide it by 2, because that's what we set up here, right? To find the midpoint between the distance of between two complex numbers, we take that number and divide by 2. So it's really just going to be what was z plus w? Okay, well, we don't know that yet, so it would be 2 plus 6, so that'd be 8. Okay, that would be 8. Let's see, z would be 2 plus 3i, and w would be 6 plus I, and then divide that by 2. So we would have 2 plus 6 would be 8, plus 3i plus I would be plus 4i all over 2, and that simplifies into, if I can divide both of those by 2, so I end up with 4 plus 2i. Okay, so this would be the vector z plus w, okay, divided by 2, sorry, z plus w divided by 2, okay. So once I have this, then this now written in coordinate form would be 4, 2, and that would be the midpoint of PQ. Okay, that's the midpoint of PQ. This would be the midpoint of the segment PQ, because that's halfway between this distance. All right.